So good afternoon to everyone. It's a pleasure to be here addressing you all for the first time. And I wanted to share with you a little bit of what we already discussed here through Fernando and through Steve on what is the outlook growth for SinterCast going forward. And I would start to do that by displaying in this slide first what is the current situation of SinterCast and how we got here and how we generate value. So as we have seen during the previous two presentations, a big driver of growth of CGI in the market were the increasing and more demanding emissions legislations. So if we look at this graphic, we see Euro 4 back in 2004 was the big hitter, and then from then until now to the Euro 6, where we are, we were pushed to increase every time more the efficiency of our engines, and Euro 7 will follow, and the engines will have to be even more efficient than what they are now. And to achieve this, naturally, you have to increase the peak firing pressure you have inside of an engine. And if we look back in time to in Euro 4, back in 2004, it was around 210 bar. Currently, we are at 250 bar of pressure, and to be compliant in Euro 7, we have to increase to 270 bar the pressure inside the engine. And you can only achieve this kind of material resistance if you shift from the conventional gray iron into CGI material. And that was the trend over the years. So we see that back in the Euro 4, DAF was the first one to come on board with a CGI engine. Short after, when we got the Euro 5, DAF came with another engine, then MAN came on board, Navistar in the US, and Hyundai. And we estimate that by that time, 15% of the new trucks being sold, because this is applicable for trucks, they have a CGI engine in it. Yeah, either both the block and the head, or just the block or just the head. But there was a CGI component there, improving the efficiency of that engine. Then back in, or after, at the beginning of the Euro 6, then Scania came on board with the 13-liter engine and with the 16-liter V8 engine. Then Daimler in Germany also came aboard, and Hyundai increased their portfolio in CGI. More recently, you have Traton with a new common-based engine, the 13-liter engine that will serve both Scania, MAN, and International. You see FAW also in China making the move towards CGI, and we estimate that currently 40% of all new trucks produced and sold annually, they have CGI components in their engine. Looking forward for Euro 7, Steve already mentioned the case of Iveco or Fiat Powertrain. They are launching their new generation engine in CGI, and others will follow. Yeah, we know that other OEMs will also follow this trend. So there's a very big growth opportunity going ahead to Euro 7 and the next years. And this image you also saw, our market exposure, it's on the big vehicles. Yeah, passenger vehicles represent 1% or less than what we do at the moment in terms of material application for CGI. And reflecting on how do we add value as a business, we all here at SinterCast, well, primarily we add value to society because we enable the production of a material that effectively lowers the emission of CO2 in a hard-to-abate sector. It's not easy to electrify a truck, it's not easy to electrify an off-road vehicle, and that's where SinterCast applies the material that it helps to produce. Annually, we estimate that we save 10 million tons of CO2, and this number is always increasing as the number of vehicles that are driving on the roads also increase every year, because we always sell new vehicles every year. Then naturally to foundries. Our technology enables foundries to produce CGI in a more efficient way and with lower scrap. I mean, out of my 20 years of work in foundry and doing CGI in these 20 years, I realized how complicated it is to produce the material without any kind of technology support to improve efficiency. And CGI, it's made reliable at foundries due to the implementation of our technology and our support. And then naturally to shareholders, because we are able every year to share the amount of value that we can capture from our business and distribute to all of the shareholders. Then how do we see our business going forward and our added value going forward in the next years? Well, we already discussed here a bit the regulations, and we see on the left side the regulation for electric or for passenger vehicles in the US, and on the right we see the same for the European Union. And both of them are based a lot in the uptake of battery electric vehicles. And as we discussed also today, it will not be easy. And looking at data from 2024, we see that in the US, 9% of the vehicles were electric and 91% had an internal combustion engine in it. Yeah? And the share of hybrid vehicles in the US, it's very small. Looking to Europe, we see that only 14% are battery electric vehicles and 83% still have an internal combustion engine in it, either if they are the regular diesel or petrol vehicles, or if they are hybrid, they still have internal combustion engine inside. And naturally, what this shows and we realize is that we are short on the objective that we should have. So if you see in the case of the United States, they hoped to be at 26% in 2027. They finished last year at 9%. In Europe, we estimate that to comply with the 2025 targets, we should have 28% of battery electric vehicle penetration this year. And last year we were at 14%. So there's no way we are going to meet our environmental targets. And what this means is that we are also hurting a lot the economy, because OEMs invested a lot of money developing their electric platforms and they can't sell it because the market will not take it. Yeah. So and how this is being addressed, as we all know, the new administration in the US elected a new direction for the EPA agency, and one of the first measures that they took was to put the running regulation into review. And this will mean most probably that they will lower the targets that they have set before. And also important, they will probably cut a lot of funding for the development of the electric infrastructure. In Europe, as I mentioned just before, we are lacking in the uptake of battery electric vehicles, and as Steve said, in order not to cause much damage to the OEMs, the European Commission decided to renegotiate the target, and now they have 3 years so that in average they can meet the target they had to comply in the current year. So what is the opportunity for SinterCast in this context? And naturally, when we look at it, it's the hybrid vehicles. We see here the breakdown for the last 2 years by quarter of sales for electric vehicles and for hybrid vehicles in Europe. We see an anemic growth of the battery electric vehicles, but we see a steady growth of hybrid vehicles. And as Fernando just mentioned before, we put a lot of hopes on the solutions that are provided by the ultralight project. So having a small compacted CGI engine that it's better for the environment in the production phase as aluminum, that can deliver higher performance than the aluminum engine for the same weight, coupled with the development that OEMs are doing and are advertising in binding together the internal combustion engine with the electric motor. This will bring much more impact in the environment than waiting for the uptake of the battery electric vehicles. So we hope, and we are supporting 2P naturally to promote the benefits of the ultralight engine so that it is adopted in the future by the OEMs. We have some work to do there naturally because they have to change their mindset in terms of material, but they see the opportunity on hybrids. You see Toyota investing on hybrids. You now see Porsche investing. Daimler announced the development of a new engine to be used in hybrid vehicles. And 2 years before, they only talked about development of battery electric vehicles. So this has changed in the recent times. Looking at heavy-duty vehicles, we have the same scenario. The regulations are not so stringent as they are for passenger vehicles, but they go in the same direction. So they are pushing for the electrification or the use of hydrogen in fuel cells for heavy-duty trucks. And again, we see the same trend. So the US realized this is not the way forward, and they are going to revise the regulation. This was what caused will cause most probably the delay of the implementation of the EPA 27. And we see that in Europe, if we want to achieve the targets by 2030, we need to achieve a fleet that has to be 100% electric for the local distribution. And here we are talking about the smaller trucks or the trucks that make the daily deliveries in the city where they have the electrical infrastructure there. They always return to the same starting point where they can charge. And these ones have to go all electric. But that's also not where SinterCast has its main business. We have the main business on the long haul trucks. And there, studies report that at least 10% of them will have to go electric for us to comply with the 2030 targets. This also means, although it's a tough target to meet, also has the meaning that 90% will still run on internal combustion engines by 2030. And to enter in what is the alternative then to diesel, I would like to share with you this graphic. Seems complicated, but I will break it down very easy. So this is a simulation on looking at the European road vehicles. What is the best mix of different fuel sources that you can use in the European road transportation sector in order to have the lowest possible emission of greenhouse gases until 2050? Yeah? And what we see, we conclude three things. Electricity are the blue ones there. All the other ones are other sources of fuel. And we conclude one thing. We conclude that battery electric or the use of electricity will not be or is not the solution that causes the lowest emission of greenhouse gas emissions. Second, we see that 2/3 of those fuels are to be used in internal combustion engines. Yeah? Independently of what kind of fuel they will burn on an internal combustion engine. And third, there is an urge to replace diesel by other solutions that are better for the environment in the short term so that we don't have to wait 10 or 15 years for the development or the availability in price and in infrastructure for hydrogen or any other type of alternative fuels. So looking at the current scenario, we see that the trucks that we at the moment have in operation, they have already available fuels that they can use. And this is the case of HVO, biodiesel, and biomethane. So if you have a diesel truck, you can fuel it with HVO. If you have a natural gas truck, you can fuel it with biomethane directly without making much changes into your engine. And these fuels, in analysis from well to wheel, they have the potential to give up to 90% of CO2 reductions compared to diesel. So we don't have to wait all these years to have a better solution in battery or on fuel cells if you can opt for these fuels in the short run. Then you have e-fuels that naturally will require green electricity, green hydrogen, and will capture carbon for the atmosphere to be done. They are not so efficient, so they consume 3 to 6 times more electric energy than the amount of energy that they deliver as a fuel, but it's a technology in development. They will get better. And then you have the hydrogen option that can be used in fuel cells. You can burn it in the engine, and it's the real zero emission solutions that we have going forward. And why do I say this now? Because the other three alternatives, they are what it's classified as CO2 neutral fuels. This means that the truck will still emit CO2 at the exhaust pipe. But the thing is that the production of these fuels will also consume CO2. So we are just circulating CO2, taking it out from the environment and from waste especially, turning it into a fuel burn it and deliver this back to the environment without adding up to what is now existing. This is already allowed in the US. In the European Union, it's being considered in order to be allowed as well. So the passing of the last revision of the emissions legislation had the Germany opposing to approve the regulation if this clause that we see here, the clause 17, was not included in the regulation in a way to open the door to regulate the use of CO2 neutral fuels in the future and allow them as an effective contributor to reduce CO2 emissions. And the best thing about all of this is that all of these engines will still benefit from the use of CGI. So all the benefits we see from diesel, we will also have here, reducing the consumption of fuel and making them always more efficient. Then looking at some recent news, we see DAF just last month announcing that their 13-liter engine, to which we support the production at the moment in CGI, it's already available to work on B100 biodiesel. It was already possible to use HVO. Now they can also use B100 fuel, so saving up to 90% of CO2 emissions immediately. And we also see at Scania, if we take a deeper look at Scania's website and we go to the evaluation that they do on renewable fuels, we find this this summary where they show the different renewable fuels that you can use in their internal combustion engines and what is the estimate or typical reduction in CO2 that you get well to wheel in the current situation in Europe, in the current operation. And they also show the one for battery electric vehicles. And if you look with attention, the one with battery electric is the power source that gives the lowest reduction in CO2 in analysis of well to wheel. So all of the other renewable fuels, they are a best short-term alternative than battery electric vehicles with the current electric supply grid that we have. So to finish, if we look at the heavy-duty sector, around 1.46 million trucks are produced and sold per year in these three main regions. 1.44 million, they are trucks with an internal combustion engine on it. So this means that 2% are zero-emission vehicles, and then the other 98% are internal combustion engines. And we estimate with the data that we have and that we collect from foundries, from competitors, that 40% of those trucks have a CGI engine in it. Again, both head, block, or just head, or just block. Fast forwarding into the future to 2030, what we see is this scenario here. Even if electric vehicles, battery electric trucks and fuel cells take 10% of the market, our data indicates and our studies indicate that 80% of the trucks produced and sold by 2030, they will have a CGI engine in it. Yeah, and a very short amount will be still gray iron. If we put this in numbers, we will see that by 2030, zero-emission vehicles will sell 150,000 more vehicles than what they sell today. If we look at CGI, we see that there will be 800,000 more vehicles produced in CGI or with engines in CGI by 2030 compared to what we have in 2024. This means that going forward, CGI will grow 5 times more than zero-emission vehicles by 2030. So we have a much greater opportunity of growth in CGI than we will ever have in any zero-emission vehicle alternative. And SinterCast, as a market leader in the technology, has a big share of this production and will continue to have a big share of this production going forward. So looking into the future, we see that there is a big growth opportunity from our current business. We will have bigger volumes, we will generate more value for the industry, and it's in our hands also to capture more of that value to give back to the shareholders. Thank you.